Get started. I thank you for your flexibility in working with me today. We're going to do a quick little video here dealing with the multiplication of radicals. What you're going to find here, though, is the combination of multiplication with the addition and subtraction. I know we kind of looked at it a little bit yesterday. We just want to go a little bit further with it today. Next week, we'll jump into what happens when we bring the equations back into the focus. Now, as far as these expressions are concerned, make sure you're comfortable with these first three that I have here on the left, recognizing that, hey, they're each different radicals, but they only have multiplication inside. So we can break it down by looking at each factor separately. Just be careful to watch what root you're working with. So this first one here is the cube root of 8 and the cube root of x to the 9th. All right, which will end up giving us 2x cubed. Now, it's nice when it works out to an even value where we don't have any radicals left over, but that's not going to be the case all the time, as we saw yesterday. So you'll see here with this next one, we're dealing with 12 in the square root of x to the 4th. Well, x to the 4th is nice. That's just x squared, but you do have to break down the 12 to 4 times 3. So that'll give us 2x squared square roots of 3. So that 3 gets kind of stuck in there. Now, as far as the priority is concerned here, make sure you deal with your variables. Like if anything, I say from a simplifying standpoint, definitely make sure that we're trying to get variables out of the radical. Not that it always works out nicely, but make sure we try. Now, as far as the next one here, if we're using the approach to look at them separately, what you'll see is that cube root of 54 is not going to work nicely. But also when we get to the cube root of y to the 5th, it's not going to come out as nice as maybe we want them to. Slide those out of the way for a second. But as far as factoring is concerned, you'll see here with 54, we can do 27 times 2. And for the y, we have one group of 3 with 2 left over. Okay, so make sure that you're paying attention to like just a quick division whenever you have an exponent involved. So this will give us 3x to the 4th y cube root of 2y squared. Making sure to connect it back, of course, to the fact that this 2 and this y squared are the only thing that's left inside. As far as this y cubed, well, that's one group of 3 that goes with our radical. As far as this 12, hey, 3 goes into 12 4 times. That's where I'm getting x to the 4th from. And make sure to connect the 27. The cube root of 27 is where I got the 3 from. Now, that's just me looking at a couple different ones. We haven't done as many cube roots, so I wanted to make sure to do a couple cube roots. But you'll see yesterday, this is what we jumped into, is dealing with this idea of combining like terms, right? Using the simplification to create like terms when possible. Now, what I hope you saw from this first one is, hey, I can just jump in and do the subtraction. They already both had the square root of 7. 5 minus 2 is 3. Just don't forget the square root of 7. As far as these other two are concerned, if you get stuck with something, you're not really sure what to work with as far as the perfect square, just start factoring. All right, and always focus on repeated factors. So you'll see here, hey, I have 3 2's. So what I could do is rewrite this first one as the cube root of 8 times 3, or if you prefer 2 cubed, you don't have to do it 8. I'm doing the same thing with 192. I believe we could divide out a 4. That'll give us what, 48? I do another 4, that'll give us 12, and then another 4, a 3. Now, if you take what I told us yesterday, though, focusing on this one, we're going to have a 3 left over. So you could have just said, hey, how many times does 3 go into 192? Well, you'll find it goes 64 times. That'll allow us then to write that cube root as 64 times 3, which will be 2 cube roots of 3 plus 4 cube roots of 3 for a total of 6 when we do the addition. By the way, for all of you joining in, make sure you put your first and last name in the chat, as long as with whether you're in my 1 o'clock or my 2 o'clock class. Do we feel okay with this segment? Is there any questions here that I can help someone with? We didn't really do a cube root yesterday, so I just want to make sure. Now, I put this last one on here just as a review. We did this back in module 4. Just remember, as far as this is concerned, is hey, I can distribute to get to the next step. Okay. What we're going to find as we bring addition, subtraction with multiplication mixed in, distribution is our focus. Okay, so that's what we're going to look at next, is how do I handle the multiplication when I have, say, a binomial involved, and it's not just a single radical like we see with the square root of 2. What you'll find is distribution is our answer. So for this first one here, we would say, hey, this is 3 times the square root of 2 plus the square root of 5 times the square root of 2. Now, going back to the properties that we talked about, we can multiply these two together because they both have a square root. So we're allowed to multiply those two. The first two, however, we're just going to write it as 3 square roots of 2 plus square root of 10. So we won't be able to multiply the 3 and 2 together, but we can multiply the 5 and the 2 together because they're both inside a square root. One thing that you do have to prepare to do, though, is to check to see if you can simplify here. Won't happen all the time, but let's go look at this one. So here we have a binomial times a binomial. So whatever way you like to do, if you like the FOIL process, make sure you use that. Just remember here, we're still distributing. We just have to do it more than once. So going through that process, I'll get 2 times 5, which is 10, minus 2 times the square root of 3, plus 5 times the square root of 3, minus the square root of 3 times the square root of 3. As we stated before, the 2 here, I cannot multiply with the 3, so I'm just going to keep it as 2 square root of 3. The same thing with the 5 here. I'll keep it as 5 square root of 3. At the very end there, there's a couple ways you can handle this. First and foremost, see that we can definitely multiply them together to give you the square root of 9. But also remember, a number times itself is that number squared. So the square root of 3 squared is just going to give us 3. So that's one of those things, if you recognize like, hey, square root of 3 times square root of 3, that's just 3. There's nothing wrong with that. That would just go back to what you're comfortable with writing. But we definitely want to make sure to see, like, once we get there, whether you write it as the square root of 9 or recognize it here, make sure you're simplifying down to 3. The reason we want to do that, though, is this time we have like terms that we can combine. Where the first one, we had to stop because we had 2 and 10. So they weren't like terms. Down here, we have 2 constant values and then 2 terms with the square root of 3. So we could say, hey, 10 minus 3 is 7. And then 5 minus 2 is 3. Just don't forget the square root of 3 when you do these two here, bring it down. Any questions or concerns there with these? I see several people are joining in. If you haven't done so, please make sure you put your first and last name in the chat for me with what class you're in, the 1 o'clock or the 2 o'clock. Now here I have a couple other problems that we can look at. Now, hopefully you'll see distribution, the foiling process is the same thing we did before. The part that we have to be careful of again is just knowing when we can multiply something together and when we can't. So this first one, when I distribute, they all have square roots. So we can definitely go in and say, hey, this is the square root of 12. And over here, it's either just 6, or if you need to, again, put plus the square root of 36. The other step then is just say, hey, can I simplify any further? So like square root of 36, that's just 6. Whereas with 12, as we've seen before, we can break that down to 4 times 3. So the square root of 4 is 2, and then the 3 we have to leave inside. That one thing to always watch for is if you have a duplicated square root at some point, as I mentioned with this problem and the previous one, you're going to have just that value through the multiplication. Okay. It's like when we go look at this one here, at some point, I'm just going to have a 7 somewhere. So if we go through this process, we would say the square root of 7 times the square root of 7, and then the square root of 7 times the positive 11, oops, times the negative 11, and then 11 times 11. Now, this one's interesting though, because if you remember, this is the factors of a difference of square. It kind of follows that pattern of a squared minus b squared, where these are both the same thing down here. Only thing that's different is the signs. A special name is given to these factors. This is going to be where we talk about conjugates. Okay. And the idea there is what you'll see was once I'm done doing this work here, these two middle terms are going to go to 0 because one's positive, one negative, the same term. And all we'll have left is the 7 minus 121. So give us what, negative 114. There's no radical left over though. So when you multiply two conjugates together, they both had a radical to start with, but the result of the multiplication will not have a radical in there. And this is only true for square roots, a difference of squares. Any questions or concerns here with these two? All right. So the next problem I had, hopefully didn't delete. There it goes. Is just reminding us, watching out for exponents. So when you break something down that has exponents, just make sure you remember to write it twice. And then go through the distribution there. So 5 times 5, the 5 times the negative square root of 2, and the square root of 2 times the square root of 2. Now, the big difference you'll see here, this wasn't a difference of squares, right? We weren't multiplying conjugates, so I still have a square root of 2 when I'm done. The nice thing about it is you can always look back to see, hey, this was being squared, so 5 plus 5 is where the 10 comes from. Okay. It's still negative, though, because that's what was going on here. As far as the 23 is concerned, well, that's a squared plus b squared. Well, hey, that's that times that. And I messed up, y'all, because that should not be minus. It shouldn't be 23. Square root of 2 times the square root of 2 should give me a positive value there. So I should have had 27 minus 10 squared root of 2. So I apologize for messing that up. Now, what I hope that you see here is that these problems, right, as far as the multiplication is concerned, it's more about just being careful with your distribution, right? Going through that process of first times first, outer, inner, last times last, or box method, whatever way you're comfortable with. The big difference is I can simplify some terms sometimes. Okay. So the other example of simplifying terms was like we saw here when we did this multiplication, I got that square root of 12 involved. So I was able to simplify that. Is there anything I could clear for somebody though with these?